In this video, we're going to look at how to create an Excel calculator to do t-tests for what are called paired means, matched means, or dependent means. Basically means you have two sets of data that have some logical matching. Usually it's like a pre-test and a post-test, so each person is measured twice, or it's just something that these two sets of data have a logical pairing, a one-to-one pairing, like test scores for siblings or test scores for spouses, those types of things where you've got a logical pairing of the data. You'll notice that the formula for doing a t-test for what is called these dependent means looks awfully similar to just a standard old t-test for one mean, one set of data. And that's because it really is the exact same test, because instead of the average of your one set of data, you're taking the average of these Ds, and these Ds are the difference scores from the two sets. And then instead of the hypothesized mean of the one population, this is the hypothesized average difference between those two populations. And then instead of the standard deviation of your sample, it's the standard deviation of all those difference scores, and then square root of n is exactly the same. So you can see that's exactly the same. If we literally just took all of our difference scores and put them in this column, our calculator that we created earlier for just a single mean with data would already do it for us. So really, that's all you would need to do, right? You could literally just paste your data. Let's say I've got some data here. I'm going to paste it right here, and these are my two samples. They're paired up, right? They're the same size, obviously, the same size of samples, because they have to be paired up, right? This one's paired up with this one's paired up with this one, and so on and so forth. So be careful. You can't sort your data because they're paired, right? These are two scores that came from like the same person, or these are the two siblings or the two coworkers, or for some strange reason there's a match, and you have to leave them this way so that they're matched up. Okay, then the next thing you need to do is just create a difference column, and this is going to equal this minus this, sample 1 minus sample 2. Drag this down, and we just created a bunch of differences. All right, so let's go over here. Let's get rid of our data, delete that, clear that out, take this, do Control C. Now here's where we have to be careful. We have to Control Alt V. We have to paste special, because if you just paste, it's going to try and paste the formula, and it's going to try and add two, or take the difference between two columns to the left of it that don't exist. So instead you want to tell it, no, don't deal with the formulas, just paste the values that are in those cells. And so then that's how that works. And then it automatically reran it on those, and here's our sample size, right, of 18 things. Here's the mean of these numbers, standard deviation of these numbers. Here's the t-stat, because we're basically saying the null is that there's no difference between them. The mean difference, right, was 9. So you can see that we have a really, really tiny p-value, so we would reject the fact that there's no difference. Let's say we think, okay, there's a difference of 10. And then look what happens to our p-value. It's saying, well, yeah, we can't reject that because the difference of the two samples was 9.2. That's pretty darn close to 10. If we thought it was 5, we can see that it's now getting far enough away from 5 that it's thinking, it could be, but there's only a 3% chance that that's true. If we're talking about a one-tail test. If we're doing a two-tail test, then it's always doubled. But that's it, guys. That's how easy it is to create or to use what we already have to do a dependent means test. But you could also always go to your data analysis toolpack, and it does all of the two sample stuff. So our two paired sample for means, we would say, okay, here's my first sample, click on here. Here's my second sample. Click on labels, because I did highlight the labels. I always like to do that, so then when it prints out stuff, I know what it's for. My alpha is 5%, meaning that's what I'm going to test for. the hypothesized mean difference, right? We're going to go with 5, like this one, see if we get the same results. And then hit OK. It's going to give you a new sheet with your results. Here's the mean of the first one, mean of the second one, blah, 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 right? How many observations, degrees of freedom, here's my t-stat, here's my p-value, and so on and so forth. The only thing it doesn't really give you is it doesn't give you the, the mean of the different scores and things like that. But it does give you your test statistic, and it gives you the p-value if it's a one-tailed test, the p-value if it's a two-tailed test. It gives you the t-critical value that you're testing against as well, if you need that for anything. So you could do it either way. I like to just use these rather than the analysis tool pack, but the analysis tool pack is also, quick and easy. I just like to practice doing programming, so to speak, in Excel. Okay, thanks for watching.